Hey Team GChem, Dr. Vivi here with a quick office hours chat on some tips and tricks for dealing with Lewis structures when we're dealing with multiple central atoms. So if you've looked at homework 7.2, you might notice that one of the harder problems on the homework is dealing with Lewis structures for larger molecules. And in particular, when we have to deal with larger molecules, like both the examples that I've got shown in green here, we may have to deal with more than one central atom. The good news is often how the structural formula is written gives us a hint as to how the atoms should be arranged. So I'm going to go through two quick examples to show you how to read and interpret some of these hints that are embedded within the structural formula. Okay, so let's start off with our first example. This is CH3CH2OH, better known as ethanol, even better known as booze. And this molecule right here might seem intimidating at first because there's a lot of atoms going on. It's hard to know what the structural formula is. But how structural formulas are often written is to show you kind of how the atoms are lined up. We know the hydrogens are not going to be central atoms. They're going to kind of dangle off. But within our non-hydrogen atoms, you might notice that there's a carbon, and then another carbon, and then another oxygen. And how these structural formulas are designed to be written is to show us that in the ultimate structure, those linker atoms are, in fact, going to be linked together, exactly as is shown in the formula. And then the hydrogens, the reason that they're written multiple times is to show you that each of those hydrogens is connected to whatever nearby element. Normally, it's whatever element is to the left, but every once in a while, you'll see it as being the other way around. So these hydrogens are going to belong to this carbon. These hydrogens are going to belong to my second carbon, and this last hydrogen is going to belong to my oxygen. So I can go ahead now and write out my structural formula. Got 3 hydrogens on the first carbon, 2 hydrogens on the second carbon, and then last but not least, 1 hydrogen on that last carbon. I'm not going to go through this in detail, although if you want to come to office hours to chat about this more, you can feel free to do so, but it turns out once you go through all the steps for Lewis structures, our final structure for this molecule would look something like this. We've got our structural formula, and then going through the other steps would help you know that to come up with the correct electron count and make sure everything obeys the octet rule, we end up needing 2 lone pairs on this oxygen. Our second example, we're going to go through CH3COOH, also known as acetic acid or vinegar. And the reason that I want to do this second example is you might notice that the first oxygen is written in parentheses. You're not always going to see this in the literature, but when you do, it's a sign that, in fact, this oxygen is not going to be part of the overall chain. It's going to be one of these outer atoms. So we can, again, look at our various atoms that show up in the chain. Now I'm not only ignoring the hydrogens, but I'm also ignoring the atoms that show up in parentheses. And we can see once again, it looks like this molecule is actually pretty similar to my last one in terms of the main linear chain. We've got a carbon, and an oxygen. And then once again, I can place my other atoms around those elements. So these 3 hydrogens belong to this carbon. This oxygen is going to belong to my second carbon, and the last hydrogen will belong to my oxygen. So here, my skeletal structure will look something like this. And you can go ahead and take a minute, see if you can go through all the steps now that we have the structural formula to solve for the Lewis structure. I'll go ahead and give you the final answer, which is that in this complex, once you go through all the steps, you'll realize that we need a double bond and a couple of lone pairs showing up on the different oxygen atoms. So that is basically it for when it comes to dealing with central atoms. There is a little bit of guess and check involved sometimes, but normally you can get a good hint as to what the structural formula will be based on how the formula itself is written. Hope that helps. If you have follow-up questions, please come to office hours and I'll be happy to chat. Bye, folks.